name is Jessica Fremark, and this is my thesis Self-Driving that I worked on during my last year in Franklin's Gymnasium in Mölndal, Sweden, where I live. My mentor for the thesis is Veronica Aspvall. We have all been in a real long boring car queue, only to find out that there really wasn't any reason to stand still. A queue that forms without there being any real obstacle is called phantom queue, and it's caused by a lack of interaction between drivers, too short distances, and human reaction time. Since modern cars with adaptive cruise control have virtually no reaction time at all, my hypothesis is that a queue of such cars could drive both faster and closer together. This thesis intends to investigate this and try to find a possible remedy for such phantom queues. I use self-driving model cars to simulate the occurrences of phantom queues, and then I measure how the traffic flow changes when the cars use adaptive cruise control. According to research done by Ford, the problem of phantom queues could disappear if all cars were equipped with adaptive cruise control. Likewise, an American computer simulation shows that the optimal traffic behavior could improve road capacity by as much as 100%. By using programmable self-driving cars, the problem can be tested in practice and still hopefully be relevant to the real phenomena. Using 3D software and a 3D printer, I created 6 identical cars that were programmed to be self-driving, using line and distance sensors and an Arduino. To be able to simulate both fully automatic cars and human drivers, the speed of the cars and reaction time of the adaptive cruise control are adjustable. Then, I put the cars on a looping track in a queue and took measurements with different reaction times. During my project, 2 tests were made, each with adaptive cruise control and human reaction time. The first test was used to find out the distance the car needed to be able to stop before an obstacle. I measured the distance and tuned the cars to get them to stop as close to the obstacle as possible without gliding. The graph shows the distance left to the obstacle, with different settings from when to start braking. This minimum safe distance simulates the real-life case when the car in front of you brakes and comes so close to you have to stop completely. We can see that the cars with adaptive cruise control have much less variation than those with human reaction time. This is because the sensor is not checked as often, which stimulates people reacting differently. I, for example, react faster than my grandfather. The second test is what the whole project is about, a simulation of a queue. Will phantom queues disappear completely or at least be reduced with adaptive cruise control? The test is to find an optimal distance between cars where no car has to stop completely, even if the car in front brakes. These graphs show for which distance between cars a phantom queue happens. We can see that the human drivers end up in a phantom queue every time, regardless of the distance, probably because they need somewhere around 120 centimeters, which is longer than the longest straight of my test track. For the cars with adaptive cruise control, phantom queues disappear already at 40 centimeters distance between the cars. Now these tests will be visualized in a video.
I'm American made, but a large Chevrolet. My mama taught me wrong from right. I was born in the South. Sometimes I have a big mouth when I see something that I don't like. I gotta say it. We've been driving this road for a mighty long time, paying no mind to the signs. Well, this neighborhood changed, it's all been
The measurements indicate that 40 to 70% more of the cars used in this program could be used in the same road without phantom queues occurring. The result is on par with the theoretical computer simulation I mentioned. Could this be a solution to the ever-increasing traffic on our roads? Instead of spending taxpayers' money on widening the roads, existing roads could be put to better use if all adaptive cruise control were mandatory in all cars. Thank you for listening to my project.